Right.
Hey guys.
No.
Or was it tomorrow?
Did you sign it?
Because that day when we were doing it, we did it back to back Monday too. We did it Monday.
That was right.
Maybe I did do it today. I didn't have the paper no more.
Is this still
We're sort of working our way into the next section here. Point, we're sort of, this is going to be our segue between the last section and the next section. What do you think you could do here?
Do you have the inside?
Convert them to fractions and add them.
Yeah, this is why fractional notation for roots, fractional exponents. So normally the way to have them, if you have to do something to your problem, these are not the same root. That's going to be hugely important here in a minute. I can't somehow combine these because they're not really like in the right way.
Not yet.
Not yet. But if I do change, what would this look like if I made it into a fractional exponent? Good. On the bottom is the power. On the top is the, on the bottom is the root. On the top is the power. What would this look like?
X 1/5.
Good. Root on the bottom, power on the top. And now, add. And of course, to do that, I need common denominator. I like it. What's really interesting, when you make a common denominator, what would that be? 15. So this would be 10/15 plus. Now really think about what you just did. This is the 15th root of x to the 10th. This is the 15th root of x to the 3rd. They would have the same root then, wouldn't they? So finding an LCD is making the roots the same. Because you can't multiply two root expressions unless they have the same root. Let me say that again. I know in this form I have to get an LCD to add these powers, right? But the bottom is the root. So the more general way to look at this is I can't multiply two things unless they have the same root. That's the same thing as saying they have the same denominator, because that's the root. So what do you, of course, here I just get x to the 13/15.
But you could leave that one.
Do what?
You could leave it in that form and just find the LCD. Now that we know that.
Yeah, so you can make this, then you can see like 10/15 and 3/15. You can actually do it like that. Let's not do that yet. This is fine, and we can see the fraction is better.
When would you subtract?
If I divide.
So that's it?
That's when you subtract powers. When you divide. So if I had the same kind of setup, except I had divided by 5th root of x, I'd do the exact same thing. Right? What does this look? It looks like x to the 2/3 divided by x to the 1/5. What do you do with powers? Subtract. So it'll be x to the 10/15 minus x to the 3/15. Sweet. Right? How are we doing so far? So I know when I multiply, I add powers. I have to write it in the form of a power before I can add the powers. But I want to point out, when you find an LCD, you're making the roots the same. So it actually points to a requirement. I can't multiply two roots unless they have the same index, the same root. So let's see what that really means. If I have the square root of 7 times the square root of 11, do they have the same root? Yes, so I'm allowed to multiply.
Wait, so you multiply the 7 and 11?
I love it. And let's really analyze why. I know you guys don't trust it when it looks too easy. This would be 7 to the 1/2 times 11 to the... Now watch this. Can't I take a 1/2 out? Right? Do I have to do that? No, thank God I don't have to do that. That's why I'm allowed to do it. If they're the same roots, that common root would come back out. Unpowered distribution, right? So then I just get 77 to the 1/2, which is the square root of 77. Let's screw all this. Same root, multiply, square root of 77. Done. So if, well, yes.
So, let's say if you were to multiply numbers that would, let's say if you got, like, 64 square root, then would you have to simplify?
Yes, good. At the end, you would simplify, as always. So the square root of 77, I can't do a damn thing to. But if I got the square root of 49, you would say that's 7. You'd go one more step.
And then that's why, because 77 can't be square rooted, that's why.
Yes,
you have to
and
simplify.
not nicely.
Okay.
There is a number that's the square root of 77, but it just never stops, so we won't do that.
So there's never a set way to answer. Sometimes it's going to be root and sometimes it's going to be answer.
Oh, because they mean the same thing. They mean the same thing. This is the answer, and so is this, because they're the same thing. It's sort of like if you get x over 3 as an answer and somebody else gets 1/3 x, you're both right. They mean the same thing.
So it doesn't matter which way you do it.
Only if I say, and I will sometimes say, leave your answer in root form or leave your answer in exponential form, right? If I don't say, then either way. So can you do this?
Yeah.
You can, it's better than me. That's some new math. Because do they have the same root? No, so then no, I can't. Do they have the same base? No, it's a 2 and it's a 5, right? So even rewriting them in exponential form is not going to help.
So, on
Well,
problem
hold on, why
one,
not?
they still have the same base, even with the exponent?
They have the same base because they're both based on x.
Okay.
Yeah. So here, if you do rewrite it, this would be 2 to the 1/3 times 5 to the... What's the rule when you multiply like bases? Oh shit. Do I have like bases? No. You with me? So you can't say x squared times y cubed is anything to the 5th power, right? Because the base is not the same. The base has to be the same to be able to apply that rule.
That's not XY local block?
Definitely not. Because I have 2 x's and 3 y's.
So, what if the 5 was a cubed root instead of a squared? Then would you be able to play with it?
Yeah, if this was a cube root, then I could just say cube root of 10. If they're the same root, I can just multiply them. Hell yeah.
So the answer to this would be 10.
Would be this.
So we can't do simplify the latter one? No, because there's a root.
You could do some stuff, but it doesn't get you anywhere nice. I mean, if you make an LCD, you can't add them because they're not the same base, but you could take it out and have some stuff left inside. Is that worth anything? No. So the important thing here is if the root is not the same, you're not allowed to multiply the insides. But look here, the root was not the same. So I can't just multiply that by that. How did we get around it? The insides were the bases are the same. So I am allowed to do a little something. I am allowed to simplify it a little bit.
But those X's are representation of a real number,
And the same one.
okay? But those are also representations of
But
a
are
real
these
number.
the same real number?
They're the representation of the power of 1,
No.
because it's 2,
Is this
5, 1, 1, 1, 1.
are these the same numbers?
Not the same number.
Good. These are x and x, so they are the same number. So that's why I was able to do more here. Nothing here is like. Are the insides like? Are the roots like? So I should be surprised that I can't really do anything with this. The roots have to be able to... So if I had this instead, cube root of 2 times cube root of 5. What would that be? Cube root of 10. I'm allowed to multiply the insides because the roots are the same. Yeah.
You don't simplify that?
Which part?
The
This?
root of 10.
Oh, this?
Yeah.
How simplify?
Well, I mean, like, do you have to break it down? Like, the 10, the 5, and 2, or?
Is there anything in 10 that there's 3 of? No. There's only 1, 2, and 1, 5, and I know that because that's where it came from, right? But it's a good question. In general, if this was an 8, hell yeah, you got to keep going, right? Oh, if it was minus in the middle, we're not there yet. Yeah, right now we're just talking about multiplying and dividing. Next we'll talk about adding, subtracting radicals.
Where did you get the 4/3 and the 1/2 again?
Oh, this is trying to be a 1. Because what's the power here?
1.
And what's the root?
3.
3. So power on the top, root on the bottom. Power on the top. Understood 2 out there, right? Good. That's where it came from. So that's how you write any root. Power on the top, root on the bottom of the fractional power. Yeah. Okay. Yes, sir. Okay, I can do that.
So what do we write? Cannot do, or?
Yeah, cannot simplify, or already simplified, or give me the next one or something.
Just put not nice.
Don't just not put anything. I can't give you a nicer problem because there's no work to do. Yeah.
Sorry, how did you get 1/2 again?
Here,
Yes.
what's the root?
It's 2.
Second root, right? Understood to be a 2. So the root's on the bottom. The power is understood to be a 1. The power's on the top. Always. So square root of x is x to the 1/2 power. Because what's the square root do to something? It cuts it in. Bam. Cube root cuts it in thirds. 1/3. 1/3 power. Yeah.
Alright, so for multiplication and division, either the powers have to be the same or
The
number,
roots have to be the same,
or the
bases have to be
Okay,
the same.
I got it.
Or else there's one of those two things has to be true for me to be able to do something.
That makes
Good. Okay. Something useful anyway, yes.
Okay, and I don't know if you've covered this, but we found the lowest common root, right, or the common root, and we before with the difference.
So let me do this. So I said earlier there was something you could do. I love you guys to death. There is something you do. It's not worth anything, but I'll do it once just so you can see that it's not worth anything. What would the LCD be here? And why is that not by itself? It's like, why would I ever do that? These are not like. I can't apply that rule. So let's try it. 6. So it'll be 2 to the 2 6 times 5 to the 3 6, right? Which would be. Now let me see if you guys are with me on this. I can't add those, can I? Please, dear God, because they're not like bases, right? But I can do this: 2 squared times 5 cubed. Pull a 1/6 out. Don't they both have a 1/6 in them? Wouldn't this get me right back to there? Do you like this so far?
No.
Neither.
Why is it not 10?
Say again?
Why is it not 10 and then 5 over 6?
I can't multiply the bases unless this does not say 2 times 5.
So going back up to the
What is
This says this many 2s times this many 5s, right? It's the same reason I can't say 2 squared times 5 to the 11th is 10 to the 13th or something. And I know that's really tempting, but I always tell students, how the hell do you see 13 10s? I see 2 2s and 11 5s. I don't see 13 10s. There's only 2 2s. How many 10s could I make? Do you guys get that? I could pull two of these 5s off, and then I can make 2 10s. That's just playing with a freaking number. It's not a better way to write it, but I definitely cannot be this. You guys with me? So I'm not multiplying 2 by 5 here. It doesn't say that at all. I'm multiplying 2 2s by 11 5s. There's really nothing useful I can do to it. Yeah.
So basically you're saying we can't do that.
Thank you. Yes, but I had people that didn't trust me.
You're just saying a lot that I'm not sure.
Yeah, so in here, what do I get? 4 times 125, which is 500, I think.
Yeah.
To the 1/6. That's all you can really do. Is that really any better than this in any real way? Sort of, but not really. And you can imagine these powers can get high. Yes?
So you're saying that we can't do that because it's not 2 times 2 to, or 2 to the second power
Yeah.
times 2 to the
If I had 2 to the 1/3 times 2 to the 1/2,
Okay.
now I could do
5 to
something.
the second and 5 to the
Yeah, so this would be 2 to the 2/6 times 2 to the 3/6. It would be 2 to the 5/6. That makes sense, right? Okay, cool.
There is, it's 2.817269114.
Okay. I'm glad.
Or we can just
I can sleep tonight now. Okay. And by the way, this explains to you how you can find like a 5th root on your calculator. If you don't know where the X, the root button is, you just raise it to the 1/5 power. Right? So if you want to know the 5th root of 800, you say 800 to the 1/5. Put in parentheses, and it'll do, that's the 5th root. Now I've lost my train of thought. Where am I going? Oh, good. So real quick, if I had square root of 50 divided by square root of 2, what do you think I'm allowed to do here?
Cancel the square root.
Square root of 25.
Square roots definitely do not cancel, because this does not say square root times 50, square root times 2. Division can only cancel multiplication, right? So you can't cancel a symbol.
Then simplify the side.
Yeah, they have the same root, so I'm allowed to divide. The same way I would be allowed to multiply if they have the same root. So square root of 25, which is 5. Okay, cool. So multiplication is really the same thing as division. So if I just need common roots to be able to multiply, I just need common roots to be able to divide. Yes,
So
ma'am.
now what if that was, like a 3 on the outside of square root of 50
So
over,
So a cube root of 50
yeah. You could-
over the square root of 2?
Yeah.
Same thing as that other problem. Can't really do anything that's worth anything.
Okay.
Yeah.
So why wouldn't you do that one like we've been doing it, where you do 50 to the 1/2 times 2 to the negative 1/2?
Because they're not like bases. It's not going to get me anywhere. So you just did a really good point for me. You either have to have like bases, and I can do what you just said, or you have to have like roots, in which case you can do what we just did. Right? One of those two things have to be like in order for me to simplify this.
So the negative 1/2 is not like 1/2. In that form right there, right? Or not that form, but you do the 50 to the 1/2, and then the 2 times 2 to the negative 1/2.
Yeah.
So they're not.
So you could take a
Not
1/2
like.
out, 50 to the first times 2 to the negative 1. Why do that? Yeah. This is still just means divided by 2, right? So just flip the 2 over. Okay. Okay, cool. Now don't get me wrong. I really don't want to... I love questions. I don't want you to think I'm going... You guys certainly don't hold back. Questions are beautiful. Just allow me to tell you that there's no value in something and just accept it. See me afterwards if you don't believe me, right? Because I may be wrong. See me afterwards and I'll apologize next time I'm wrong, but see me afterwards. All right, so let's get somewhere. Okay, here's where this is all leading. If I'm allowed to do this, what is that? So if I'm allowed to do that, I'm allowed to do something more useful, which is actually the other way. This is sometimes useful because I sometimes come out to something I can simplify. Yes, sir?
On that one, if it was the cube root of 50 and the cube root of 2, then would it be...
The cube root of 25, which can't go any further.
Right.
Good. I like it. But you can still at least do that first step. If I have the square root of 98, this is sort of like having, if you circle that as your answer to something, you're wrong in a way. It's sort of like circling 4/8 as your answer.
Because you factor it.
Because you could do something further, right? 4/8, you could reduce it. Now this is called simplifying radicals, but I actually call it reducing the radical. Doing the part you can do and leaving the part you can't. So if I did have something like 4/6, that's 2 times 2 over 2 times 3. So I divide the part that I can and I leave the part that I can't. Are you kind of with me? Mm-hmm. So square root of 98, there's a number inside 98 that the square root could do. 49. if I'm allowed to put two square roots together, I should be allowed to tear two square roots apart. So square root of 98 is square root of 49 times square root of 2. Right? What's 98? 49 times 2.
So it's 7.
Yeah, square root of 49 is 7. Square root of 2 is, I don't know, square root of 2. So you do the part you can, like this, and you leave the part that you can't. Yes?
So this is what is going to come when you have 7 rad 2 plus...
Yes, I love it. You're there. We're getting there.
Okay.
Yeah. You'll see the first main reason why we want to be able to do something like this. I like it. Now, I want you to understand, this form is a little bit better than this form by itself, but there are other purposes for doing this. So we'll see that here in a bit. John kind of gave us a little hint for one.
So like on the other one, it was 50 over square root of 50 over square root of 2. Why did the 2 disappear there?
Because it's both the same root, so I'm allowed to divide. 50 divided by 2 is 25, yeah. Cool.
Why is it 7 root 2?
Because the square root of 49 is 7. Square root of 2 is square root of 2. So the biggest mistake I see is somebody tells me the answer is
square root of 7. So that's 9. Why isn't there a square root? Why isn't 7 inside the square root?
because the square root's already been done. You would never stop. What is the square root of 49? 7. The square root of 49 does not equal the square root of 7. Because it's like, when would you stop? Cut it in half, cut it in half again, cut it in half again. It's like, stop. This just says cut it in half. So the minute I've done that, it's gone. Cool. Well, I'm glad you brought that up, because people do often tell me square root of 9 equals square root of 3. No, square root of 9 equals 3. The square root symbol's gone because it did its job. Okay, how we doing so far? So this is what I call, the book calls it simplifying radicals. This is what I call reducing the radical. Because it's very much like reducing a fraction. It's kind of the same idea.
This is easier.
Yeah.
Huh?
So this is easier.
Yeah, this is kind of nicer.
Matrices.
Oh, the matrices, sure. Okay. Yeah. If that's your baseline, then... I hate that I just said that, because it makes you sound that hard. You just knew. You guys are like, that makes me feel good, Jeff. All right, sorry. So how would I do cube root of 80? So reduce that, simplify this. What's your first step? Our first step here, where'd the 49 come from? It was a square that was in there. Why do we want to look for a square? Because it's a square root. So what do we want to look for now? A cube. So what cube, what number that is a cube is in 80? 8. So then you want to break it up as 8 times something, right? So this would be the cube root of, let me write it like this. This is the cube root of 8 times 10. And then you break that up. Cube root of 8 times cube root of 10. You guys with me? That's the reverse of the, they have to have a common root to be able to multiply. Well, then I can tear them apart as a common root. I can go either way.
The, kind of backing up one. Would you have to put plus or minus 7 times?
No, definitely not. Because remember, when I have this symbol, it means the positive root. If I want the negative root, I have to have a negative sign there.
Okay.
Yeah.
Look at 2 cubes.
Yeah. Would that be 2?
So cube root of 8 is 2 times cube root of 10 is, I don't know. Do the part you can. Don't do the part you can't. All right. Sounds like a life philosophy. Grant me the wisdom to know the difference. All right. So now, ready for this? Let me throw in here just a little bit of something we did last time. I don't know if you guys remember this. And we're going to marry it with something we just learned today, right? Which is legal in this state. If I So remember last time, we certainly did something simple like that. A squared. I know the answer value, but remember we took it up the next step. We said, what if I had this? I don't know if you guys remember that.
Yeah.
So another way to look at what we did, if you don't like the shortcut I showed you, and why does the shortcut make sense? Why does this make sense? Why would I divide 4 into 8? Well, how would I rewrite 4th root of a to the 8th as a fractional power? Yeah, so I am dividing. So roots would be on the bottom of the fraction, so that's why it only makes sense that a shortcut is just divide the root in. But does 4 go into 9 nicely? No. 4 goes into 9. Let me do it like this. Good Lord. 8 to the 9th, isn't that 8 to the 8th times a? You see, I'm kind of trying to make it like what we just did. You don't have to do it this way, but this is why the way we do it works. But if you like this way, you can do it this way. Why do I break it up like this? Because 4 does go into 8. And times the rest. Right? That's the excess.
So
8
squared.
A squared.
4 through 8.
Oh, yeah, sure. Yeah, 9 goes into 27. Yeah. So 4 goes into 8.
2 times.
Twice. 4 goes into 1. No. So it stays inside. So that extra a stays inside. Makes sense. Do the part you can. Don't do the part you can't. So the shortcut, 4 goes into 9 twice with 1 left over. Done. Yes, ma'am.
So if you have any odd number where the 9 is, would you always separate it like that? With the 8 times
Well, I mean, if I had, get way up on my Roman numerals. If I had like let's just do a 4th root. 4th root of b to the 23rd. If you want to do it this way, 4 doesn't go into 23. What's the next number down it goes into?
20.
So I'd break it up as 20 and 3, the excess 3. 4th root of b 20 times b 3. That's the thought process. 4 doesn't go into 23, but it does go into 20, and the 3 is actually the remainder. So you guys see why the shortcut works? 4 goes into 23 5 times. That would be this part here, right? With 3 remaining. I like it. This is why it works. This is the shortcut itself, but you can do it this way if it makes more sense. Because I know we like to be able to see what the hell, where things are coming from. I don't blame you on that. Hopefully. Okay, so here's the ultimate problem.
We're still on 10, 12, 2, right?
We're in 12. We're sort of in 12.2 and 12.3.
Okay, we're combining.
Yeah. There's a lot of overlap between the sections, so ask me any second, I'm probably in a different section. I'm up to 9. Okay. So if I had the 3rd root of 81.
All under 3.
Still like directions, yeah. Yeah. Make sure everybody's in the right direction. What's kind of bad about the number 81 by itself with the root?
Because it's a square root of 9, but not a cube root.
Yeah, 81 is, you can square root it, and you can 4th root it, because you got 3, but you can't cube root it, so you're going to want to break it up, right? So that you can have a part that you can do the cube root of. Make sure you leave a little 3 on it. This is 22, not a 32. But for what you had, it was right. Good. And then all I gotta do here is. That's an end, it's a 9. Alright, good.
Alright.
So this will be 27 times 3, right? And you can do the cube root of 27. Good. But no, that would be out here.
Oh, okay, so
Because the part that you can't do,
but how do you do
it's
it-
left inside.
How do you do with the variables?
So let's see. 81 is. So the cube root of 27 is 3. So it's. I didn't take anything out of the radical. I was able to do it. So that's why it's out here. Right, so it's not quite right to say, I can't just take something out of there. I have to do the radical, and then it comes out with no radical on it. So what's left inside number-wise? So that part, the cube root of 27 is there. That 3 is still there. That extra 3 there, right? Make it 3, Jeff. 3. 3 goes into 9. Anything left over? No. 3 goes into 12. And no. 3 goes into 22. With 1 left over. So you see what I did? The minute I started taking like numbers inside, I left some room, so I had room for my letters. You with me? So I took the 3 way over there, put the 3 that was left there, and then I started looking at the letters. Guess
Wait, why did you subtract that?
subtract what?
Because you're the 12 and I have a...
3 goes into
Just
12
kidding.
4 times. Because how would I write this fractionally? 12 over 3. Well, that is 4. This,
How come you didn't write the 27 on the outside?
because I can't just take a 27 out. Right? What is the cube root of 27? There. So right here, this by itself, what did I actually do to this? I wrote it as cube root of 27 times cube root of 3. Too many 3's here from.
I just did 9, 9, and 3, 3, 3.
Yeah. That's what I did.
Sure. All right, let me show you something. Good. I was going to show you this. This is beautiful. Why? No, definitely. Why does it look like numbers act differently than variables? I don't just divide 3 into 81, right? Because that's not what this is saying. This is saying that the cube root of 81. But I do divide 3 into 9, don't I? Because there's not a 9 in there. There's no 9 in there. There are 9 A's in there. And for every 3 A's, I take 1 out. That's what a cube root does. Cuts it into 3 parts. So, if I rewrote 81, just look at 81 by itself. Isn't that 3 to the 4th power? 3, 3, 3, 3?
Yeah.
3 goes into 4. Once with 1 left over. Right? So you can never just have something inside a radical and the next step it's outside now. Cannot do that. I didn't do that. I took the cube root of 27 and wrote a 3 because that's what it is. That's what the cube root of 27 is. Yeah. Go ahead.
Instead of doing 27 and 30, could you do 9 and 9?
You can't do the cube root of either one of those though. Because each 9 only has 2 3's. You need something that has 3 of something in it. Yeah.
So once you have variables, though, that's when you divide.
Yes, because,
Okay.
and again, it's not even that. I want you to really understand. The minute I wrote 3 with a power, then I treated it the same way I did each of these. Because that A to a power, B to a power, the shortcut is divide the root into the power. Are you with me? So if I write my number as something to a power, I could do it the same damn way as the letters work. So why don't they work the same way? Because this is not factored. These are. So they're not going to work the same way. Of course not. Unless you factor the damn thing, and then you can do that. So that's my suggestion. Some of you guys might want to rewrite your number as something to a power, and then you can treat it the same way you do these. Unless you don't like the way I treat these, and then we need to work on something. Let's do another one of those. Let's see. Yes. 10. Let's see. Oh, let's see. How evil can I be? A really good idea. I hope to God you guys know a bunch of squares, right? You should know a bunch of cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. You should know some fourth powers. 2 to the 4th is 16, 3 to the 4th is 81, right? We know that one. What's 2 to the 5th? 32. See how I said that slow? Somehow maybe that has something to do with something. I don't know. 2 to the 5th is 32. Right? You should know some of these powers so then you know what numbers to look for the associated roots. Yes. But we're looking for fifth roots. Something, now look here. Oh. So I love what you've done. Isn't that 2 here also, right? So 3 times 3 becomes 2. Put that there. Now the fifth is looking for 5 things. Do you have 5 of something? Yeah, so the fifth root of this piece is 2. And those will stay inside.
Can I combine them to be 9?
I agree with that.
What's up? Yeah, that's good. Yes, beautiful. And now work on the letters. It's fifth root. Always your 5. Yeah. Good.
So I have 2.
Yeah. Good.
That's right.
So with that, slacking more than 12 to match with the remaining 2.
Yeah, that's it. That's how you did it.
Will it still be
Yeah, 5 goes into 12. So 2 A's can come out if they square. And the 2 left over inside.
as an exponent or
Yeah, it's got to still be an exponent.
on the A?
Yes, on an A, yes. But you're talking about how many A's. There's too many A's in there.
So
If only this was a 10. So I know my answer is going to have those extra 2 A's in there. Because they're the little dorks that made the problem harder. If they were just not there. So they just get to stay in there. So this guy, you can do one of 2 things. A fifth root has got to almost be based on 32. Almost for sure.
Really?
But in general, but in here, yes. In the real world, it can be based on any damn thing it wants to be. But so I'm going to try to do 32 and then divide by 32 and I get 9. Another way to do it is to take 288 and just start breaking it down. Right? 2 times 144. 12 times 12. 3 times 4, 3 times 4, 2 times 2 times 2 times 2, 1, 2, 3, 4, 5 2's. Fifth root is looking for 5 things. Since I have 5 2's, the fifth root of that stuff is 2. And what's the fifth root of 32? 2, because 32 is made up of 5 2's.
what do you put if you can't do the fifth?
At all, you just leave the number in there. So if I said the fifth root of 12, there would just be a 12 sitting there.
Do you have to take
You
everything
can't.
else out?
You can't. 12, you can't break it into 5 nice parts.
Yeah.
You can break it into 5 parts, but they would not be
So
nice.
even if it was 12 and then A was 12 and B was 52, you just leave everything in
No.
Okay.
The power, which power in here is not big enough to do anything with?
C3.
Yeah, fifth root needs 5 things. He's only got 3. He's going to stay in.
Yeah.
So fifth root of 32 is 2. Inside there's still the 9. Right? Do the parts you can. Don't do the parts you can't.
Okay.
5 goes into 12 twice with 2 left over. 5 goes into 52. 10 with 2 left over. 5 goes into 3. No, but a times there.
Put a times there.
You don't have to, but I just had too much space there. I want to fill it with something. All right, so enough of that. Let's go to something else. It does not mean go home. We're not doing that yet.
Why is the 9 there?
Say again?
Why is the 9 there?
Because 288 is 32 times 9. Yeah. And 32 is a good number because the fifth root can be done. Good.
So, is it still wrong if you put 3 times 3?
In a way, because you should just simplify. If you do 3 times 3 here, just replace it with 9. Yeah. Okay. So I want to get back to John's point earlier. In a second. Actually, I got one last thing to do with this section here. When you're dividing, let me start over with a pie. Let's look at dividing. So, one level of division is simple. We've already looked at it, where I had something like square root of 50 over square root of 2. So we looked at that one earlier. That's nice. So as long as it's the same root, you can divide. What I'm talking about is the more complicated stuff. When you have like 2 over the square root of 7. Fundamentally, there's something kind of not good about this. I want the radical to be on its own, and I can have like a fractional coefficient. It sucks to have a radical. Radical by itself is freaky, but to have it on the bottom is like double freaky, right? So I don't know if you guys have ever heard of this. We're going to what's called rationalize the denominator, right? What's a rational number?
A real number?
No. This is irrational. A rational number is any number that can be written as a fraction or the decimal. Well, actually, it includes anything that can be written as a fraction, really. So decimals that stop, decimals that repeat. Square root of 7 is ugly. Poor little dude. If you do it in your calculator, it's just going to go as far as it can. There's not going to be any pattern to it, nothing. So square root of 7, square root that I cannot do is an irrational number. So to rationalize the bottom, I want to make it into a rational number on the bottom, right? Rational numbers are bad. I don't want to divide by them also. So square root, why can't I not do the square root of 7?
It's irrational.
I like it. It's irrational because of the fact that I can't do it, but why fundamentally can I not do it? Why can I do the square root of 9? Why can I do it? Because 9 has 2 3's. Square root is looking for 2 things. So what's he missing?
2 things.
Another 7. If I gave him another 7, couldn't I do the square root then? Wouldn't it be square root of 49 there? Right? So if I multiply, can I just multiply by 7? Because what's square root of 7 times 7? Can you do that? Good. You need the same root. Just multiply by square root of 7. So you kind of give him what he's missing. I call it completing the root. If it's a second root and you only have one thing in there, give it another one. How do you do that legally? Do it to the top too. Now everything I've done is legal. So on the top I just get
2 root of 7.
2 square root of 7 divided by 7.
Yeah, 2 root 7, not square root of 14 because it doesn't have a root on it, right?
Over 7.
I love it. This would be the square root of 49, which is 7, but don't even do that. This kind of completes. Isn't this half a 7? And this is the other half of 7, so it makes a whole 7. Isn't this 7 to the 1/2?
Yeah.
Times another 7 to the 1/2 makes a whole 7. If you want to look at the square root of 49, which is 7. Can I cancel the 7s out?
No.
Not the same root. Right? So I can't do that. Again, so this would be rationalize the denominator. In calculus, there are times when you want to rationalize the numerator also. We'll let calculus work. There will be some problems actually in the homework now, just think about it, but they do ask you to rationalize the numerator. It's the same thing though. So I really want to see who kind of hung on to what was important up here. People look at me and say, oh, you multiply by the same thing. That's not what's important. That's not even what I did. I looked to see how many 7s does he need. 2. And I gave him one more. So if I had 2 over the cube root of 7.
Let's give him 2 more.
Beautiful. So you look to the root. You don't just multiply by the same damn thing. That's not going to get you anywhere. He's only got 1 7, he needs 3, so he needs 2 more. So what are you going to multiply by? Well, square root of 7 squared is not good. Why is that not good?
Because they cancel each other out.
Well, these cancel each other out too, but I'm just doing something, same thing top and bottom. To be able to combine with this needs to be a cube root. Same roots, so you can actually combine them, and you just give him however much he's missing. That sounds a lot like some stuff we did before, right? Give it what it's missing. So that's why I call it completing the root.
So what would the top be?
The top is just 2 cube root of 49. Right? 2 times cube root of 49.
What square root of 49 can't be 7?
I don't have a square root of 49. I have a cube root of 49.
Oh, just kidding.
So it's unfortunate almost that we don't put a 2 here, because you associate this symbol with a square root. So then when I do this, that's when I had people saying 3 square root. But that is a cube root. We just don't write 2, right? That's the only square root, is when there's nothing written. That's a cube root. On the bottom, I'm going to get 7. Because I would get cube root of 7 cubed, but that is 7. Yes, sir?
What if you had a square root versus a cube root? Would you be able to multiply the square root by 3 to get like 6 and then the same thing?
Like we were doing earlier. Yeah, if you needed to somewhere. Yeah.
To make the square roots the same.
But I multiply by the exact same root, so I won't have that problem, right? So if I had 5th root of x over the 5th root of y cubed, you do it, Jeff. How much does the bottom need? It's a 5th root, so it needs a total of 5. How much stuff does it have right now? 3, so it needs how many more? 2 more. Right? In order to be done, a 5th root needs 5 things. It currently has 3 y's, so it just needs 2. You see how this works?
No.
Shit. What's the, what is the 5th root of y to the 5th? Y. What's the 5th root of y to the 4th?
Y.
Can't be done, right? It's not enough. So if I can do something, if I have a cube there, if I have that sitting there and I'm allowed to give it 2 more y's, and I know that means I could do it, then I would do that, wouldn't I?
Yeah.
So I can't do the 5th root of y cubed, but I am completely allowed to multiply by the missing 2 y's. Why is it missing 2 y's? Because then it would be doable, right? I'm completely allowed to do it because I have another side, at the top side, right? So if I multiply the bottom by 5th root of y squared, I have to at the same time multiply the top by 5th root of y squared. Yes, sir?
So that has to go with, if you went back over to that, you could rationalize the top.
Yeah, I mean, if I had this, it'd be the same thing we're doing, just I'd end up with all the radical stuff on the bottom.
Yeah.
Okay.
Right? And right now it's weird to understand why we would need to do that, but
So the top would end up being 5th root x y squared.
yes. So I want you to realize we focused everything on the bottom. We did what we had to do to make the bottom work. So what's going to happen to the top? Whatever happens. Who gives a shit? Right?
Okay.
We're focused on the bottom. Who cares what happens? Everything just gets, since they're the same roots,
Yeah.
I'm allowed to put them together? Yeah.
Why?
So with real numbers, it's just you combine or you add what's missing, but with variables, you go for the exponent, right?
Yeah. Yeah. And you actually do the same thing, both ways. Because again, if I had
The original thing I was thinking was, okay, fine, you have y to the third, then you need
Right.
four
if I
more
had
of those y to the
4th
thirds.
root of a squared b over the 4th root of 27, do I give this 3 more 27s? That is one way to do it, but that's a crazy way to do it. No, the one though. Because 27 is already 3 3s. So it only needs one more 3.
So 27 times 3.
So it works the exact same way. I have 3 3s, I have 3 y's. This needed 2 more because it was a 5th root. This needs 1 more 3 because it's a 4th root. So you give it the one it's missing. So on the top, you just get 3a squared b because of the same root. I can just slap those together, right? Whatever happens up there, happens up there.
So you don't add the
Bottom
roots.
you get 3.
You don't add the roots, you just get whichever one.
Yeah, you definitely don't add the roots. It's sort of like the root just extends over the other stuff. It's a 4th root of all of this stuff. Over the 4th root of 81. So the 4th root of 3 to the 4th is 3. Woo! So that's why I like to call that completing the root. Makes a little more sense than just saying rationalizing the denominator. You're actually completing the root, giving it what it needs to be done. Done. So last thing I want to say, and then we'll leave almost on time. For once. You spoiled people. Coming back a little bit to what you're saying, and what John was saying earlier, no, screw it, until somebody asks me, I won't say. What's your gut tell you? It's definitely not square root of 10. Beautiful. Because what is square root of 5? I don't know. So in algebra, what do we do when I don't know something? So what's x plus x? Do it. Something I don't know plus the same thing as 2 things I don't know. So root 5 plus root 5 is 2 of these things. Right?
Right.
Good. I want to make that point now. It's not square root of 10. Don't give me that shit.
Do you have to put the square root even though it's in line with the square root?
I have to put the square root or else nobody would know it was a square root.
No, I meant like little 2.
No, I don't. But that's not what that 2 is.
No. Do you have to put another one up by the...
No, because it's understood.
Got it.
Yeah. So like putting over 1, that's understood. So what if I had square root of 50 minus 2 square root of, what do you got, Jeff? 98.
You try to
You can't.
Are they like terms?
No.
So I can't do anything the way it's written right now. Do not make this negative 2 square root of 48 or something weird. Right? You can't put those together. They're not like terms. But I can simplify, right?
7.
I'll tell you this.
49.
In order to be like terms, what's going to be left over here is root 2, right? There must be a root 2 left over here, so 2 goes into 98 49 times, and 49 is a square. Once you get one of them done, it's kind of a hint for the other one to try at least. So what's the square root of 25?
5.
Minus twice, what's the square root of 49?
7 square root 2.
So I got 5 roots of 2 minus 14. So whatever's out there is multiplying, so whatever ends up coming here multiplies.
So negative 9 right 2.
Yeah, so 5 of these minus 14 of these is negative 9 of these. So that is an immediate use of that simplification of a radical. Right? This was totally not doable until we simplified, and then it was totally doable. So, just in case you're curious, that was actually...
Is this where the variables come from? We're getting into variables now.
How do you mean?
We're going to start adding x's and minuses and pluses.
Oh yeah, that'll be in there too. Yeah. So we actually just got a little bit into, believe it or not, 12.5. So if it feels like we did a lot,
It's because we did.
we did. Yeah.
What chapter are we going up to?
12. Tomorrow we're going to make it into 12.6, and then the rest of the day is going to be a review. Which reminds me, you probably want to get the practice test. So you guys have nothing but time to do this. Do as much as little of that as you want to. I'll answer you tomorrow.
I'll get that quick.
Whoever answers that, no. Because I wouldn't have enough time to grade it and get it back to you before the test.
When is the test?
What?
would that be due to the day of the test?
Oh, it is? Well, it's the next test.
Don't forget maker season.
It'll be on the next test. I'm not gonna throw them out. It'll just be on the next test.
You said that if we can get,
Okay.
we can get corrections on the
You can correct it with no matter what
we
test.
have to get a C.
Yeah, the average is C at the end.
12.6. 12.6 would be the last one.
All right, guys, go take a nap.
And then I'm going to the math center to review before my test at 8:30. But you said my